What is Varignon's theorem for quadrilaterals? Imagine drawing a shape with four sides and wondering what happens if you connect certain points inside it. That's where Varignon's theorem comes into play. It's a neat rule in geometry that helps us understand the inside of any four-sided shape. Whether your shape is a perfect square, a slanted trapezoid, or a weird irregular figure, this theorem still works. It's like a magic trick that always shows a special shape inside your quadrilateral. Here's how it works. First, take your quadrilateral and find the midpoint of each of its four sides. The midpoint is the exact middle point of each side. Once you have those four midpoints, connect them in order. When you do this, no matter what kind of four-sided shape you started with, the shape you get will always be a parallelogram. A parallelogram is a four-sided shape where opposite sides are both parallel and equal in length. This new shape inside the original quadrilateral is called the Varignon parallelogram. One interesting fact about it is that its area is exactly half of the area of the original shape, as long as the shape doesn't cross itself. So, if your original shape covers 10 square units, the parallelogram inside will cover 5 square units. This is true no matter how irregular or skewed your original shape is. Another cool detail is that the perimeter of this inside parallelogram equals the sum of the lengths of the diagonals of the original quadrilateral. That means if you measure the diagonals of your original shape and add those lengths together, you get the perimeter of the inside parallelogram. This connection makes it easier to analyze and understand the properties of the original shape just by looking at its inside. This theorem is useful because it links the properties of a quadrilateral to those of a parallelogram, which are often simpler to work with. It helps us see how midpoints and diagonals relate inside any four-sided shape. So next time you have a quadrilateral, try finding its midpoints and connecting them. You'll see a perfect parallelogram from inside, revealing a hidden pattern that's always there.